Hello everyone, welcome to this talk by Angelos Kyrlidis. He's the R&D director at Cabot Corporation, one of the largest producers of carbon black worldwide. He has years and years of experience working with nanocarbon, and today he'll be telling us about a novel nanocarbon, conductive carbon that they've developed at Cabot. And he'll be sharing a lot of very interesting data with us. So what's going to happen now is that I will, as usual, disappear. I will leave the stage over to Angelos. He will present for roughly around 20 minutes. So Angelos, just for your information, 3 minutes before the end of your talk, I will pop my head up just to give you a notice that you've got 3 minutes left. The audience, you can ask your questions on the chat. We will ask all the questions. Even if Angelos runs over by a few minutes, it's not a problem because we keep this room open for an additional 10 minutes just to answer your questions. So without further delay, without further ado, Angelos, over to you. I will make myself disappear. And yeah, the stage is yours.
Great. Thanks, Kasha, for the introduction. I hope everybody can hear me well. It's a very interesting platform for doing virtual conferences. So I have attended a few talks this morning. It's been pretty interesting. So what I plan to do today is just give you a brief overview of Cabot Corporation for those of you who aren't familiar with our company, and talk about the carbon nanostructures, this new conductive additive that we're excited about, and give you some performance results of the implementation of this material in various applications, talk a bit about the commercial status, and then basically recap my talk with a summary at the end. Cabot is a global specialty chemicals and performance materials company. We're headquartered in Boston and have been around for over 130 years. We're a global company, so we have plants in over 20 countries, and medium-sized chemical company with sales of $2.6 billion in our last fiscal year. We are very committed to sustainability and generally have leading positions in the businesses we're in. We are one of the largest suppliers of carbon black for reinforcement of elastomers in tires and other applications. We also produce carbon blacks and fumed silicas for a variety of specialty applications in our performance. Earlier, I'll just recap for those of you joining now. We're a global company founded in 1882, based in Boston. And we are one of the used for the reinforcement of elastomers in tires and other applications. We also produce carbon black and fumed silica for a whole variety of specialty applications in our performance chemicals division. And we also are a producer of activated carbon for many applications through our purification solutions segment. So this broad range of products that we offer, as well as the applications that we studied through the properties that are important in the applications, as well as the attributes of our materials. And in general, the approach that we take when we try to solve our customer problems is to start with the application, try to understand what are the requirements, what is the performance that is needed, be it optical, electrical, thermal, conductivity, for example, and then connect with the properties of our materials and try to find the right fit for the issue. As we have a lot of experience with carbon materials, we realize that there is value in some of the new forms of carbons, and we embarked on a journey looking at graphene-based materials for the last 10 years. And over the last 3 years, we've focused our attention on the materials that I'm going to be talking to you about today, that we call carbon nanostructures, because we believe they offer a very interesting balance of performance and value in use. So what are carbon nanostructures? They're a unique carbon material that has morphology that essentially is derived from its production process. It's a material produced through a continuous roll-to-roll manufacturing process where we take a catalyzed glass substrate, insert it into a furnace where we introduce a hydrocarbon feedstock, and then we grow through catalytic chemical vapor deposition a forest of carbon nanotubes that are branched and cross-linked, as you can see in the bottom left picture. And then we use high-pressure air knives to essentially harvest the carbon nanostructures that are grown off the surface of the fiber and collect these, what we call flakes of carbon nanostructures, post-coat them, and then extrude them into